Training a LoRa for Wan 2.2 has never been easier. Hello humans, my name is AI Overload, and boy oh boy do I have some mind-blowing stuff for you today. Because in this video I will quickly show you how to train a LoRa for Wan 2.2 as easily and fast as possible. I will show you how to train people, styles, and even train with videos using consumer grade GPU either locally or on RUNPOD right now. So that being said, sit back, relax, and let's go. Okay, so initially this video was supposed to be a little bit longer, a little bit more detailed, but since I already made a previous Wan 2.1 video, and since Wan 2.2 is basically Wan 2.1 but upgraded and doubled, pretty much everything that I say in my Wan 2.1 LoRa training video when it comes to the dataset creation is literally gonna be the same here. So instead of repeating myself again and again and again, and also not to waste time for the people who already watched the previous video, today I will simply show you what exactly has changed between Wan 2.1 and Wan 2.2 so that you can get the best training possible while using the less amount of VRAM. So like once again, if you are one of my Patreon supporters, you have access to all the installers for both local and RUNPOD. Obviously, when it comes to LoRa training on such a large model, I highly recommend using the RUNPOD installer instead, especially because you can choose a bunch of really amazing GPUs like the RTX Pro 6000, which is really gonna be the fastest GPU for training any LoRa for any model ever. I really wish I could have this locally, to be honest, but given the prices, I'm very happy to pay RUNPOD instead, because by using RUNPOD, you'll be able to train a LoRa completely on the cloud, safely, with a password and everything, while keeping your own computer free to do whatever you want to do. So once again, I will not show you how to install everything. You can just follow the Patreon post or follow the previous video. I mean, the installation for AI Toolkit is pretty much the same, as well as the dataset creation. So if you already have a dataset created and ready to go, then we can start the training. So once again, I will assume that you have watched the previous video, that you have AI Toolkit installed, that you have your dataset created and ready to go, created your own dataset right here inside the AI Toolkit, because now we can talk about the differences between the Wan 2.1 training and the Wan 2.2 training. Now once again, as I said in my previous Wan 2.2 discovery video, the Wan 2.2 is a very special model because instead of having one single model that generates your image or generate your video, you actually have two different models. You have the high noise model and you have the low noise model. And I also said in that video that if you want to train a LoRa, you might have to retrain a LoRa for both the high noise model and the low noise model. And well, guess what? I was completely correct, because if you actually come here and you select Wan 2.2 14B, you will see here that you have these two models right here, the high noise model and the low noise model. Meaning that yes, you understood correctly, the training will basically be twice as long compared to Wan 2.1. So if you thought that Wan 2.1 training was long, oh boy, you've seen nothing yet. I will show you a training that I have done previously that I literally had to stop after 24 hours and it was still not ready. Now sure, it was training on videos, but still, training Wan 2.2 is really super slow. Okay, so anyway, let's go over all the different parameters, what you need to change, what you need to do, depending on what you want to train, and also what are the things that you need to kinda modify compared to the Wan 2.1 training. Okay, so first, if you are using RUNPOD and you have like selected a very high VRAM GPU, well, I mean, all the parameters that you see right here, you can pretty much leave them by default. The only thing that you need to do is basically just deactivate low VRAM, because, I mean, you have enough VRAM to do whatever you want. Select your dataset, your sample prompts, the number of frames and FPS, depending on what you're training, and then, well, you're basically ready to go. I've done a lot of testing on a lot of different parameters, and to be honest, when you have such a powerful model like Wan 2.2, the parameters really don't do that much. Everything will work perfectly fine. And if you want to like make the training a little bit faster, you can just increase the learning rate from 0.0001 to like 2, and it will like train and learn a little bit faster. But I mean, other than that, I mean, everything is pretty much OK. Okay, so I will still go through a few of the parameters so that you understand what to change or what not to do. Okay, so like once again, let's say that here we are training a person. Like once again, let's say that you're training Margot Robbie. Since I already have the dataset, I'm just gonna use that. Then here you're gonna input your name for the LoRa, like call it Margot Robbie, and then the model that you're training this on. I usually just say W22, which basically stands for Wan 2.2. Now here for the trigger word, if you are using a high VRAM GPU from RunPod, for example, since we're not gonna unload the text embedding and the text encoder, you can input the trigger word right here, which is the word that you will put in the prompt to trigger the LoRa. But if you're training locally, there is no need to input a trigger word because we're gonna have to use some VRAM saving techniques. So there is no need to input anything right here. So the next, you're gonna choose the Wan 2.2 14B. Make sure to choose the correct model and not the I2V, which is the image to video. We want the text to video right here. So here you have this option that says low VRAM. Once again, if you're using RunPod, you might want to uncheck this to speed up the training. But if you are doing a local training, in that case, you might want to enable this option. So then here you have quantizations. If you're using RunPod, once again, don't change anything. You could just leave everything by default. But if you're using a local training, here under transformer, you're gonna choose the 4-bit with ARA. And ARA is basically a brand new addition to the AI Toolkit, which basically stands for Accuracy Recovery Adapter, which is basically kind of like a LoRa that allows the training for 3-bit or 4-bit quantization and still maintain a quality similar to if you were training on a normal bfloat 16 model. Basically, all that it means is that if you want to save as much VRAM as possible, just choose that option instead. It is that simple, because with a bunch of these options, you will be able to train pretty much everything with 24 GB of VRAM, at least in theory. But it's gonna be extremely long, so I really do not recommend. Seriously guys, like, choose the RunPod. It's gonna be much better than having to wait multiple days waiting for your training to finish. Okay, so then here you have the multi-stage, where it's basically gonna train the high noise model and the low noise model pretty much more or less at the same time, where it's basically gonna switch every step. But the problem is that if you have low VRAM activated, the way it will work is that when it trains the high noise model, it unloads the low noise model, and then when it trains the low noise model, it unloads the high noise model, which means that it basically takes a lot of time to switch between the two models, especially if you want to switch every step. So you actually have the explanation right here, which is why for low VRAM, a setting like 10 or 20 is recommended, because otherwise it will take a long time to do. So basically, if you are doing this locally, instead of switch every step, you might want to increase that to 10 or even 20. Everything will still work the same exact way, but since we don't have to swap the model each step by unloading the one that is not training, increasing that number will make this faster and more memory efficient. So yeah, basically, if you have low VRAM, just put 10 right here and then proceed. Then for the target, the linear rank, you can just leave them by default or put that at 16 so that your LoRa is a little bit lighter. Now do not worry, there will be no difference in quality for a model like Wan 2.2. It's just that your LoRa will be much smaller in size compared to 32 rank, but the quality will stay literally the same. So just input 16 and it will be perfectly fine. So for the save, one thing that I actually forgot to say in my last video is the max step saves to keep. So the way it works is that if you actually leave that by default, when you actually finish the training, and you have here all the checkpoints, you will only have the last 4 checkpoints available. So if your training is long and you decide that one model at the very beginning was actually your favorite, well, if you leave it like that, it is not gonna work because it's gonna be deleted. To be honest, I'm not quite sure why it's even at 4 to begin with, when the amount of steps is 3000, but what I recommend instead, change from 4 to 12, because since we are saving every 250 steps and we are going to stay at 3250 multiplied by 12 equals 3000. So basically you're going to have 12 different models to choose from, or technically 24 since there are 2 models. But this way you will never have to worry about losing a model and you'll always be able to download the one that you like. Okay, so now let's go to the training section. Here pretty much everything can be left by default except the learning rate. I do like to put that at 0.002 so that it learns faster. The original 0.0001 is a little slow, so I do like to increase that learning rate to that amount. When it comes to time step type and time step bias, technically you can leave that by default. However, depending on what you're training, you might want to change those values to get the best results possible. So when you actually click on this time step type, you will see 4 different types: sigmoid, linear, shift, and weighted. So what those time step means is that each and different type will focus on a specific portion of the model's training. So like for example, the sigmoid type will focus more on the middle, which is better suited if you want to train a character like a real person, for example, because it will allow more flexibilities for the initial image composition, so that it basically follows the prompt better and it's more like original. Then it's gonna input the face of the person in the middle, and then at the end it's gonna denoise the image to make it more precise. So if you're training a person, I recommend choosing sigmoid instead. Now the linear type basically samples the entire time step evenly, so it works, but it is less, optimized. So basically you can choose the linear if you don't want to like do any work. You can just select this one and it's gonna work. I mean, once again, you don't really need to spend that much time thinking about it. Wan 2.2 is really like a super powerful model. So no matter what you choose, it's still gonna work fine. Now the shift type basically focuses on the first time steps, the first samples, and it is more focused toward training a style, for example. If you want your style LoRa to be very, very close to your sample images, you might want to choose the shift type instead. And then finally, you have the weighted, which will basically put more emphasis on the timestamp bias that you choose right here, because then you have the timestamp bias, which is either balanced, high noise, which is where you get like the original composition, which is important for the styles, for example. And then you have a low noise, which is more for denoising and make the image more detailed. So if you choose like weighted and balanced, it's basically just gonna be like the same as neutral, for example. But if you choose high noise, it's basically gonna have like the same effect as shift, for example, because it's gonna focus on the first few frames, on the first few samples to train your LoRa. So the only thing that you really need to focus on is either the low noise first few samples, either using shift or balanced. If you want to train a style, for example, or if you want to train a character, you should choose sigmoid instead. And since we are training a person like Margot Robbie, I'm gonna keep it at sigmoid and balanced. But if after this entire explanation you still don't understand, which is absolutely fine, seriously, don't worry about it. Just leave everything by default and it will work fine. Like, this is like a super powerful model. You really don't need to worry about it. I'm just explaining this for people who might want to know what are the differences between these types and biases and the things that they might want to change to optimize their LoRa training. But otherwise, you can just leave everything by default. It's fine. Okay, so then here, once again, if you're using RunPod, you don't need to touch anything. But if you're doing this training on a local GPU, you might want to cache text embeddings, which will basically cache all the text embeddings from the text encoder and will also unload the text encoder from the GPU for the training. Hence why I told you that you cannot use the trigger word if you decide to use this option, because otherwise it will give you an error. Okay, so now you can scroll down. For the dataset, you're gonna choose your Margot Robbie dataset. Once again, you're gonna leave here everything by default. Make sure that the number of frames here is at 1 and not like 81 or 33 or whatever, or 41. Since we are training on images for a text-to-image LoRa, and we only have one image, we should only have one single frame. So in here you have a bunch of like new options called flipping. If you already trained a LoRa before using like Koya SS, you know this option very well. That allows you to like flip the image vertically and horizontally to kind of like increase the amount of dataset that you have. However, this is very situational and you will probably never use this option because you definitely cannot use a dataset of a person with a, flipped image of the face. So that's not gonna work. But if you want to train a style and you don't have a lot of images, well, this option could be interesting for you eventually. But other than that, you're not gonna use that pretty much ever. So then here for the resolutions, once again, if you are using RunPod, leave everything by default. But if you're using a local GPU, you can pretty much just, uncheck everything except 512. You'll still get a pretty good results even with the 512 resolution, but it will definitely use way less VRAM and will definitely speed up the training. Okay, so then here you're gonna scroll down. Here once again, if you're training a text-to-image LoRa with images, you don't want to generate videos, so you're gonna input 1 for the number of frames and 1 for the FPS, because we're just generating an image for the samples. Here for the sample prompts, you're gonna input a bunch of sample prompts that you want to see during the generation. You can basically input the same prompt right here that you used for the captioning of the images, and then put it right here and see what kind of image will be generated during the training. Now you don't need like 10 of them, you can just like use 5 or 4 or even less, depending on what you want. And then, well, we are pretty much done. Now you can click create job and start the training. Now I'm not gonna do it because I've already done it before. I've done this multiple times. Once again, watch my previous Wan 2.1 video. It's literally gonna be the same. In the end, you have like a bunch of checkpoints. You have 24 checkpoints, all right here. Then if you go to samples, you will see all the images that were generated during the training. And I mean, then it's kinda up to you to decide which one do you like at which step. Although don't be too serious about the images that you see right there on the screen, because since we are not using the same parameters as the one we do in ComfyUI, you might want to sometimes download a few LoRAs every like 1,000 steps and then use that in my ComfyUI workflow and generate a few images to see if you like the results. That is really the best way to find the best LoRa that you like. And at the end, once everything is downloaded and you have input your LoRa in your ComfyUI folder, and then you use my Wan 2.2 text-to-image workflow, you can get some really cool results. I mean, Wan 2.2 is really an amazing model, I gotta say. It looks really good. Now, if you want to train a style, everything that I said previously is basically the same. There is basically no differences, except that, as I explained, maybe instead of the sigmoid for the time step type, you might want to change that to shift or to weighted high noise if you want like a very strong style representation. But other than that, everything will be exactly the same. And if you want to train on videos, once again, I have explained how to create the dataset, how to prepare everything in my Wan 2.1 video. But here, the one big difference is that here for the dataset, you need to input the number of frames that you want to train on. Now, if you are using, once again, a RunPod and like a huge VRAM GPU, I suggest inputting 81 for the number of frames so that you train on the same number of frames as the original one training. However, keep in mind that it will take longer and it will also use way more VRAM. But if you want to train this on your local computer, what I recommend is put 33 instead for the number of frames. This coupled with the 512 resolution, the low VRAM, and the 4-bit with ARA should allow you to train even on videos with 24 GB of VRAM. And I'm really saying maybe. Like maybe. But even if you do, to be honest, once again, really not recommended because, for example, this is a training that I stopped at 2,250 steps and it took over 25 hours to do. Oh, and by the way, the 25 hours don't even include all the time that it took to generate all the sample videos. Yeah. And also, once again, the sample videos are also not representative of the quality that you will see when you generate with Comfy UI because it is not using the same, parameters and LoRa's that we do in Comfy UI. So yeah, I mean 25 hours for all of this, for like 2000 steps is really a long time. And this was done with, by the way, the RTX Pro 6000. And even with 95GB of VRAM, this took more than 25 hours to do. So yeah guys, yeah, it takes a while. It really takes a while. Because basically, since we are training two different models at the same time, it is basically twice as slow compared to Wan 2.1. Now, there is also one thing that I can also recommend you to do, and that is something that I also started doing, is that if you remember correctly, in my Qwen text-to-image video, I basically showcased my Qwen Combo Ultra workflow that basically showed you that the best combination to get the best results possible was actually a combination of Qwen and the Wan 2.2 low noise model, which basically first generate an image with Qwen and then add even more details using the Wan 2.2 low noise model. And basically what I noticed and what I started doing is that instead of training the high noise and low noise model at the same time, since in my day-to-day life I'm using way more often Qwen image than Wan 2.2 to generate the base image, I was basically only using the low noise model every single day. So now, if I just want to actually train a LoRa and I want to get like the best results possible, I will first train a LoRa with Qwen on Qwen image, either a person or a style, and then I'm gonna train the same LoRa with the same exact data set, but this time for the low noise model only, since I basically noticed that I never use the high noise in my workflow. And the reason why is because the high noise model is only really useful if you want to generate an image from scratch or to generate a video from scratch. However, this is something that I don't like doing because you don't get enough control over the final generation, and I prefer using image to video instead. So I first generate an image with Qwen, then I denoise it with the Wan 2.2 low noise model, and then if I want to make it into a video, I use the image to video workflow. So basically, in my personal workflow, I really don't have a lot of use cases for the high noise model. And this is something that you might want to do depending on what you're looking for. Because if you only train the low noise model instead, the training will be much faster. And if you are, like me, using the same Qwen Wan combo workflow and then using image to video, then this is probably the way to go. But obviously, it's really up to you. You do whatever you want. If you want to train both models or no model at all, it is really up to you. So yeah, there you go. This has been a very quick Wan 2.2 LoRa update video. Wan 2.2 is really like a super powerful model and you can do a lot of cool things with it. So definitely try this out yourself and have some fun. And there we have it, folks. Thank you guys so much for watching. Don't forget to subscribe and smash the like button for the YouTube algorithm. Thank you also so much to my Patreon supporters for supporting my videos. You guys are absolutely awesome. You people are the reason why I'm able to make these videos, so thank you so much, and I'll see you guys next time. Bye bye.